So just 1 minute about Synaptic. The company's been around for a little more than 10 years now. And in the early days, when it was just me and the co-founder, we did a lot of sort of AI machine learning for hire kinds of projects. People would come in and say, I'd like you to build this thing that involves AI, go build it. And we would build it and hand it over and go away. What we found through time is that companies are increasingly trying to build more complex products or projects, and so we started getting into AI strategy more to try and help organizations get themselves ready to leverage their data using AI and machine learning, a lot of user experience, kind of AI product design. And so, sort of what we think of ourselves today is that we help people build intelligent products. So, you have a thing, you would like to deploy it either internally or externally. That involves a lot of elements beyond just the AI and the machine learning, but integrating them well. And so that's what we do. So here's the plan for today. This is actually going to be a slightly different webinar. Usually what I do is I got a bunch of slides and I talk to them. Today I'm actually going to do a live demo. We'll see if we survive, but we'll see what happens. So I just want to talk about implementing agentic systems. I'm going to start out with just a couple of slides on computer programs versus agents, and you'll see why that's relevant when we start building an agent. But we've got to learn about briefly about this thing called JSON, which is used to represent data, and then we're just going to hop in. And so I've got a thing that I want to build for a particular application domain. I'll tell you about that domain that's relevant to me, but I think you'll probably see how it could be relevant in lots of other ways. And then I'll build as much of the thing as we can. So I've got kind of an end-to-end agentic system I'm going to build with a particular tool. I won't go more than 45 minutes. So if we don't get to the end of it, that's okay. I think we might get through it. So, and then we'll wrap up with a few concluding thoughts. So this is the kind of code that you look at in your very first programming course. But what's the difference between a computer program and an agent? It turns out that little box down there at the bottom shows that there's usually user interaction of some kind. There often is. There's some like how does control of computation flow based on conditions that arise, and then there's data transformation. So here is this like very notional, there's a call to say, hey, I want input from the user, and I'm asking the user to enter an integer. I have a variable I now that has the value of the integer. And then I got some control flow, which is, if I divided by 2 is 0, then, in that case, I'll say, hey, you entered an even number, and I'll be done with it. This is a very simple, standard kind of computer program where you're in control of everything, right? Here is what an agent might look like. So you might go, hey, user, give me the name of a movie. And now movie contains the agent. Sorry, movie contains the name of the movie. It's a variable. Then I might have an agent where I say, just go search for reviews of the movie that the user entered. Notice it's a very different level of control. I'm saying, I trust you to go do a web search, and you're going to know how to do that to look for reviews of a particular movie. I get back a list of reviews, and then I might hand that off to yet another agent and I say, hey, go make judgments about the quality of those reviews, right? Like I could be more specific. Do they come from like reputable websites? Are the reviews lengthy? Those tend to be better. And then I could say I've got a set of these things that are trusted. Then I could hand it to another agent that says, hey, can you look at the trusted reviews and extract and summarize the sentiment from them? And if the sentiment is positive, I could say, hey, yeah, people tend to like that movie. So again, it's user interaction, flow of control, data transformation, but the stuff that the primitives can do is just remarkably powerful. So anyway, that's just one thing to keep in mind about agents. Then the next thing I want to talk about is this thing called JSON, JavaScript Object Notation. I'm sorry, it's sort of tediously technical, but if you think about movie reviews, what I might want is I might want to figure out what's the URL, right? Where did I find that review? Maybe I'd like a date that tells me the date the review was written. Maybe I want the sentiment of the review, which can be positive, neutral, or negative. And maybe I want a summary, right? So the URL is a string, the date is a string, the sentiment comes from one of these three things, and then the summary is a string. So it turns out that it's going to be super useful to provide this kind of structured representation of the inputs and the outputs of agents in these flows. And we'll we'll see that it's actually pretty easy to create these things. We're going to let a language model do it for us. Then the only little twiddle is I can also do arrays of everything things, right? So I've got a URL, a date, the sentiment, and the summary, but then I'm going to have an array, a collection of movie reviews. And so we'll see these things kind of pop up as we're trying to build a workflow. And I'm hoping in context it'll make a little bit more sense, even if you're sort of a non-programmer out there. So I wanted a sample domain, and I chose a domain that makes sense to me. I'm also a professor of computer science, and so I'm always looking for money to fund research. And so here's the problem we're going to work on. Let's say you've got an idea for a research project. What you need to do is you need to write proposals, and we're going to, look for federal funding agencies that can support that research, send them a proposal so that we can get money back to do it, right? So part of the problem is coming up with an idea, but the other part of the problem is saying, are there agencies out there that are interested in that kind of thing? And so it turns out that agencies have websites where they will post what they RFPs, requests for proposal, or a variety of other kinds of things where they say, hey, we've got money, we'd like to invest in this kind of research. Here's sort of what we're looking for. And so we're going to build an agentic system that can go from an idea to a list of places where you might submit that idea. So as we get into that, so that's the next thing we're going to do is we're actually going to build an agentic system. So I'm going to go through that process, and that's all I'm going to do for the rest of this webinar. And it's interesting to see it happen for a real world application. I will say that I'm going to be focusing on the screen. If you have questions along the way at all, please drop them in the chat and Sam can interrupt me. So the tool that I'm going to use is OpenAI's Agent Builder. It's a graphical agentic system construction program. Is it the best one that's out there? No. And we can talk about other options that are there. I chose this one because if you wanted to go play around with it, it's trivial. If you've got an OpenAI account, you can go to the website that we're going to see in a minute, and you can start like wiring agents together to get them to do things. So it's a no code approach, which basically means it's graphical. It's helpful to think about it in sort of terms of programming, but it's a really easy way to kind of start playing around with these ideas. So hopefully everybody can see the agent builder. It knows it's me and I've logged in and I've given it, it's got my credentials and it'll charge me money for doing all this stuff. But what we'll do, we're going to build a workflow. So we're just going to click on create. And so what you wind up with is just this little canvas. We've got a start node and it points to an agent that's called my agent. We're going to dig into this stuff over here. Now, but let's click on the start node. So when you click on the start node, it says, hey, there are these input variables. And it turns out that to kick off the processing for this agent, I'm going to type something to it, right? I'm going to provide it some input text to drive that process. And it's going to call that input as text. And we'll see that pop up several times because downstream, I might want to sort of look at what is it that the user said to me to kind of kick off the process. There are also other things that you can provide as input, and I'm going to add one of those. I am going to have a variable that I am going to call, and I've got a script over here so I don't mess things up. Words range, and I'm going to make that 20 to 50. So I'm just going to add this, and what it's going to do is I'm going to use it for validating. So I'm going to provide as input an idea for a research project, and that's going to be input as text. And what I'd like to do is to make sure that it's, sort of in an appropriate range of words. It's not too short and not too long. Now we've got a couple of things that we can play with, right? So now, notice that there's a connection between the start node and this agent node. And the first thing I'm going to do is I would like to use the agent just to do a little bit of validation on the input. So I'm going to rename this thing to something useful. I'm going to call it input validator. I'm also going to change this. Now, this thing is meant to be just sort of, hey, tell me kind of sort of what am I? What kind of an agent am I? This says you're a helpful assistant. I am going to change that to you are an expert in finding federal research opportunities, right? Now, the next thing I'm going to do is I'm actually going to tell it what I want the agent to do. So think about this as this agent, this input validator, it's basically a large language model that's got access to lots of tools, and we'll see that in a minute. But it's going to get input from the start node, and it's going to take that input and then sort of do stuff to it. And so I'm telling it like your mindset is that you're an expert in finding federal research opportunities. And here I'm going to say, this is what I would like you to do. So I'm going to say, check to ensure that the number of words and I want to tell it to look at the input. It turns out here I can do two curly braces, which says, hey, I want to use a variable is boom, right? So you saw when I put two curly braces, it just popped up this little pop-up that said, here's the stuff that you can use there. Actually, it should not be state words range. I'm going to do workflow input as text, right? So workflow input as text is the input. I want to check that the number of words in the input I provided is between the words range. Okay, so we got that. All right. So that's the thing that I'm going to do. I'm just telling it, hey, just check for me that the number of words in my input query is between 20 to 50 words, which is what I did. Now, the last thing that we're going to do is we want to understand kind of what the output format is. It's a language model, and so of course it can provide text as output. But actually, what we're going to do is we're going to use JSON, right? And this JSON was this sort of structured format that we were talking about. We want to kind of constrain what the output is because we would like a downstream agent to be able to sort of, like we need to construct that agent to know what to expect. And so we're going to add a JSON schema. Now, that sounds daunting, but it turns out that I can say, hey, language model, could you generate that for me? So I'm going to say is valid will indicate if the user input passes validation tests and reason invalid will be a brief explanation of why the input is invalid, right? So all I'm saying is I'm going to have a variable named is valid that just says, does it pass the validation tests or not? And reason invalid is going to explain why it failed. So I'm going to create, and it's going to go off and do its LLM thing. And it goes, great. Okay, I see you want is valid, which is a Boolean variable. It's true or false. And here's a description of it. And then here's reason invalid, which is a string. And here's a description of it, right? So what it did was it created that JSON schema for me just by saying, hey, kind of here's what I want your output to look like. Now, I'll just point out that that gets translated into this thing, right? Which you don't have to worry about, but it says, hey, is valid is a Boolean. This is a description of what it is. The default is false. Reason invalid is a string. It's a brief reason for invalidity. And this says don't allow anything else, and I require those two. So it doesn't matter. It's fine, but you can look at that. So now I'm going to update that thing. And so now we've got our first little sort of bit of our agent wired together. So what I'd like to do is to preview it. And notice here it's just saying, hey, send a message to the agent. And I'm going to type, this is a test, right? And it says, hey, that's coming from the start node. We're running the input validator. It says, oh, here's what's going on. The user asked me to check the number of words. And actually, here's the run. We can go take a look at that. Hopefully, you can see that. Check to ensure that the number of words in this test is between 20 and 50. Sorry, in this is a test. That's it. And it goes, okay, I need to count the number of words, but it turns out that the text contains 4 words, which is not between 20 and 50 words, and false, right? So now we've got this agent that can do our input validation testing for us. And we know that it's producing this as output. It's got, is valid is false, and here's the reason that it's invalid. So now what I'm going to do is go back here and close the preview. And then clearly what I want to do, I think, is since I've added a test, what I wanted to do is to say, well, we need some conditional processing, right? So we don't want to process invalid input. So if the input's invalid, we'd like to sort of head off and say, like, that wasn't cool. We're gonna, end. Otherwise, we can kind of continue with processing. So this is just an if else, and we're gonna have a case, right? And so the case is going to be invalid data. If there's invalid data, how do I know if there's invalid data? Now, here's a little bit of a hack. It turns out that passing variables through if-else nodes is hard. It doesn't matter, but I'm just using a hack here. Instead of using that flag, which is it valid or not, I'm going to pass the reason, right? So this little bit of code here says invalid data if input, output parsed, reason invalid. If the reason it's invalid is not empty, if it's not the empty string, it seems like something invalid happened. All right. So in that case, we're going to go to an end node. And in the other case, we're going to go to an end node, right? So basically, we should be able to provide an input. It should validate it. It should say, hey, if there's invalid data, we're going to go to this node. And if there's valid data, we're going to go to this node. And so what I would do is I would say, let's test as we go. So this is a test. Notice that this thing is lighting up. It's processing there. It's going to do the thing that it was doing before. And notice that it went to the if else and it went to the invalid data side, right? So, and the reason it's invalid is the text contains 3 words. What did I type? I must not have typed this as a test. Anyway, I typed something else and expected between 20 and 50 words. So all right, so now we've got that whole thing wired up. Let's just do one more input. So this all feels very simple in some sense, in that it's not leveraging the power of the sort of full power of the LLMs, but let's do the following thing. So I am going to type in something that's different for an input that passes the test. So I'm going to put in this nursery rhyme. If you're my age, you heard Mary has a little lamb, had a little lamb. I don't know if people these days still give say those nursery rhymes to their kids. Anyway, here's a nursery rhyme. Should have between 20 and 50 words. Let's see what the processing does. It goes to the validator. It's going to think about the number of words in it. And then it goes, oh yeah, that was fine, right? There was it was not invalid, but it's clearly off topic. So what we'd like to do is to augment our agent to actually check the content. And this is where the sort of power of having an LLM as an element in your workflow is good. So notice before we said check to ensure that the number of words in workflow input as text is between blah and blah. I'll say also check to ensure that input as text, workflow input as text contains text that could be an idea that one might send to a federal agency for funding. All right. So I've simply said, check for the number of words, but then also do this like very kind of complicated thing. You ask your 5-year-old kid that, and they'd go, I have no idea what you're talking about, but an LLM can handle it. So let's go in and sort of do the preview again. I can't remember if I've still got Mary Had a Little Lamb. There it is. So let's run that. And now it says, the word count is 22, which is within 20 to 50, but the text does not describe a research or project idea appropriate for submission to a federal funding agency. So now you've got this agent, which is making a very sophisticated judgment about the quality of the input. So now we're going to kind of keep going with this. I've got a few more nodes that I want to add, but what have we got so far? We've got a start node. It does some input validation checks. We say, hey, did those checks pass? If not, we're going to go to this end node. The else clause then says, okay, well, the validation checks passed. So let's actually replace that node. And what we want to do, so remember that the problem we're working on is I've got an idea. I want to see if there are funding agencies that might be willing to support it. So the flow that we're going to do now is we're going to have two agents. We're going to have one that generates queries. So we would like some web search queries that can take our idea plus some other information, generate a list of queries that we could run. Those queries are going to be handed to another agent that actually sort of runs them and gathers information. So we'll do the same thing we've done before up to this point, which is we're going to say, all right, we need a new node. We're going to make that thing an agent, and we're going to call that node the query generator. The instructions are going to be, sorry, I'm grabbing this from off the screen. You know, here's the tone. You're an expert in finding federal research funding opportunities. Now, the prompt is going to be, oh, here's the user query. You need to find calls for proposals that might be relevant to the following idea. That, remember, the idea was created as part of our input as text, or it is our input as text. Create 4 to 6 diverse web queries to find such sources. Prioritize federal funding agencies such as the National Science Foundation, the National Institutes of Health, the Department of Energy, the DoD, IARPA, ARL, AFOSR. So these are all federal funding agencies associated with various branches of the military and the healthcare system and so on, right? So we're saying here, look at the input idea and create web queries to find sources of funding, right? Calls for proposals. But now we still need to say, all right, you're going to look at that input, but what's the output format going to be? And we're going to make it structured. So here is what we're going to say. So I've got a way that I'm going to describe it. So it's going to be JSON. I'm going to add the schema. I'm going to generate it from text. And I'm just going to say, I'd like to get back an array named queries because I'm going to get like a list of queries that come back. Each element of that array will have a query string, a priority, which is an integer with one being the highest priority, and a domain, which is the internet domain to which the query applies. So let's just create that thing. And it's going, okay, we have an array of queries. Each this array is called queries. It's got an actual query, the query string, the priority of the query, and an internet domain to which the query applies, right? So at that point, we are good to go. So what I'm going to do is let's just run that and look. And I'll tell you, I've got a, let's use this as the idea. So let's run that thing one more time. So we're going to preview. Now, it turns out that I use ChatGPT to write an idea, and I talk to ChatGPT all the time about research ideas. And it goes like, I know you. So here's, right, we're going to propose an AI framework that unifies vector symbolic embeddings with formal proof assistance to auto-construct, verify, and reuse modular reasoning schemas, enabling trustworthy autonomy and rapid hypothesis generation in STEM, right? So anyway, it doesn't matter, right? But notice that we've got, trustworthy autonomy and so on showing up in there, right? So let's hit enter on that guy. And whoops, did hang on a second? Oh, okay, yeah, it's running. So start validator. It should be the case that it says the word count, it seems to be valid. Everything seems to be okay. We're in the if else. Reason invalid. Oh, interesting. So, interestingly enough, LLMs are non-deterministic. And notice that this test said if reason invalid is empty, right? Then it's okay. This thing is saying n/a, the reason invalid is not applicable. So let's see if we can fix that thing. Ensure that the text, so right. So basically I think I need to change. This is great. This is right. So validation result. Let's actually generate this guy again. So I think what happened was we need to be more specific in our output. The default value is valid, otherwise may be empty or NA. Let's get rid of NA. Sorry, that was a little too inside. All right, let's try running it again and see what happens. All right, so now it's counting words. reason invalid is now empty, and now it's hit the query generator. And let's look at the queries that get constructed. I do want to make sure we're able to add the next one. The next one is actually the next agent, because it actually is going to go do web search. So the query, I'm deciding, right? So it's kind of thinking about things. And what it did was it generated a bunch of queries. It's a little bit easier to see it if you go to the preview, sorry, the log. And so here's query, site, DARPA.mil, BAA or broad agency announcement, which is actually the term that they use for a call for proposals, formal methods, proof assistance, theorem proving, neurosymbolic, right? So basically it's constructed a bunch of queries and it's given them priorities. Now, I have no idea how it's setting the priorities. We could exert more control over that if we want to. And then the last thing I'll do here before I wrap up is let's actually let this thing. So we're going to do the standard thing, which is we're going to add another thing here. We're going to make that an agent, and we are going to call this thing the extractor. So what it's going to do is it's going to extract information. We are going to say, you're an expert in finding federal funding research opportunities so that it gets in the right frame of mind. And then we're going to give it some instructions. And the instructions are going to be this. Let me paste that in and I'll show you what it looks like. Actually, we'll pop that out this time. So, oops. You will execute and evaluate web searches to find federal funding opportunities for the following idea. And there it is. Look at your input and execute the list of search queries. Return the 4 to 6 most relevant documents, right? So I'm telling it, you're going to go execute web searches. You're going to look for funding opportunities for that idea. There are a bunch of queries in your input. I didn't tell them what they look like. I just said, go look in your input, return the 4 to 6 most relevant documents, right? Now, the other thing we need to do, which we haven't had to do before, is we're going to turn on tool use. So we're going to add a tool for this thing. Notice web search. So now we're saying we're not going to, that's fine. We're not going to put any constraints on it. So we're going to add that particular tool. So a tool that an agent can use is basically thinking about it as it's a API, right? Like it can make calls. It understands how to make calls out of that tool. How do I send information to it? How do I get information back out of it? There are a few tools that are built into the system. So now it's got the tool it can use. The output format, we're going to go as usual. We should like JSON. And then here's the schema. And again, I wrote this. Whoops, hold on. I wrote this earlier. And it's going to be this. And we'll take a look at that. And then we'll run the whole thing end to end one more time. So output format is JSON. We're going to add a schema. We're going to generate. And I say, output a list of opportunities, one per URL. Each opportunity should include a relevance ranking, 1 to 5, with 1 being the most relevant, the due date of the proposal, and a brief summary of how the idea could be crafted for the opportunity. So this is me saying, I've got this idea. You found a place I might be able to submit it, but how do I sort of make those things kind of mesh with one another? So we'll do that. And hopefully we'll see the usual thing, a list of opportunities that has a URL, a relevance ranking, a due date, and a summary of the appropriate kinds. We just do the update. And then let's just like tie this thing up. We'll add an end node because we're at the end at that point. And output, add schema. Let's just do this manually. We're going to take the list of opportunities and say this is the output. Okay, so let's run this thing one more time, and then we'll pause and just see what kind of questions there might be. So I do have a few things to say at the end. So we're going to preview it one more time, and notice our graph is getting larger. So we're going to type that in. Hopefully it'll run to completion, and we can look at what the outputs are. So it's validating, and it's sort of doing the same thought process. Hopefully, then it hits the if else, and the if else is saying, okay, looks good. We're going to hand it to the query generator. The query generator is then saying, hey, let me throw together some queries where I might be able to find calls for proposals that are out there. And that's going to think for a little while, right? So there's the queries. It hands it to the extractor. Let's see if the extractor is doing any thinking. Hopefully it'll work. Executing web searches, search the web, search the web. Looks like it found a bunch of stuff, right? So it's sort of now it's like just going out doing web search for you, which I don't know. I've been working in AI since the early 1990s, and I'm constantly amazed at the capability of large language models and agentic systems. So let's let just a couple more minutes and it should be done because I can't remember how many queries it had. It had maybe five or six.
Tim, we had a question come in while we wait.
Okay.
Instead of saying look at your input, can we say workflow queries? Does that still work?
Yeah. So like my yes. So my one beef with Agent Builder is that what an agent sees, right? So the extractor, I think maybe I said look at your input, right? You can actually refer directly to things that come out of the query generator, right? So you could have said look at query generator dot output parse dot queries or list of queries, and that would have worked. The thing that you can't do is you can't sort of go all the way back upstream. I can refer to things that are here. So I can refer to the workflow input as text. I can refer to state variables I created here. I can refer to things that directly feed into me by name, but as far as I can tell, you can't sort of go back further in the workflow. Okay. So let's just go, hold on a second, and look here. Oh, look at that. So here's the output. It found a URL at NSF. It has a relevance ranking. There's a due date of, it's in 2026, right? So February 5th. And then here's a description, right? Pitch your unified vector symbolic plus proof assistant framework to automate conjecture proof and verification, right? So here's the URL, here's a due date. This is a Department of Energy one. And so like I don't know, I built this thing just because it seemed interesting to me, but this is actually super useful. So it's kind of rare that I go, oh, I've got a random idea. Let me go see if I can find somebody who might be interested in it. But it is the case that sometimes I've been doing work for a while and I'd like to find funding opportunities for it. So this is actually an agentic system that I would probably use. So, okay. So there we go. Let me come back and just say a couple of words in closing, right? Some concluding thoughts. So first of all, people talk about agentic AI. I mostly buy into the hype. I think that this idea of having essentially things and programs that are basically people that are really smart and capable and have access to powerful tools who can go off and do work for you is amazing. But it's not super mysterious, right? So I think the pattern you saw was I'm going to tell you what you're an expert in. I'm going to give you some instructions. You're going to get some input. Here's what I would like you to do with that input. And then what I'll do is I'll give you an output schema, right? I'll say, all right, after you're done with the inputs, here's what I would like you to output. And it should sort of be in this structure. And we just did that like boom, 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 boom down the line. So it's actually not, it's sort of easier than you might think it is. Now, there are lots of emerging low code options. So this was actually sort of a no code thing. We never wrote code and it did this sort of useful thing. There are low code options where you might need to kind of dig in and write a little bit of code. If you're interested, there is a platform called Diffy, Diffy, that if you're looking for a good kind of no code, low code, and you just want to play around with the ideas and you sort of don't want to be writing code, you can go to Diffy and the install, you can pay money and run it on the web. If you want to host it locally, that's free, but it requires a little bit more expertise. You have to run in a Docker container. I will say though that of necessity, because I'm trying to make it trivial for you to build these things and sort of not dig into code, the functionality is going to be a little bit limited. So they're a little restrictive and eventually you might need to go to code. And then I would say that like this exercise is wonderful because I don't know, you could be like a chief product officer or something at a company, and or somebody who's sort of like you're technical but you don't write a lot of code, or maybe you're just a solopreneur and you've got an idea and you want to test it out. These things are amazing for just going, oh, like this is how it works and this is sort of what the flow would look like. But I think moving these things to deployment is actually, still relatively challenging. There are a lot of issues. You got to kind of manage cost and performance, and there are lots of tricks you can play just in terms of I was using GPT-5 the entire time. You do not need the full power of GPT-5 to count the number of words in an input. And so you can do things like trying to use cheaper alternatives. So let me just one more thing, and then I promise I'll stop. So I just wanted to point out that you can't actually get the code out of this thing. So, all right, that is all I've got. I would be very happy to take any questions that there might be.
Yeah, thanks, Tim. There's a couple questions that have come in. If anyone else has questions, feel free to put them in the comments or in the Q&A section. We got asked if you've experimented with the Google ADK.
So I have not, I'll be honest with you. If you have, I'd be very curious to hear your thoughts on it.
Okay. Next is when it comes to bring the workflow from Agent Builder to production app or a web app, how would we do that?
Yeah, so what I would say is that Agent Builder is great, as I said before, for kind of scaffolding it out to have a proof of concept. You can actually take the Agent Builder workflow, you can distill it down into Python code, which you can run, but it's very simple. So it's sort of like a blob of code for each of the nodes, and then a little bit of code that kind of orchestrates the data flow between them. I think moving things to production tends to involve a much heavier lift in the sense of, again, trying to make sure that you're managing costs, and in particular, if you want to be able to serve large numbers of users on a system like this, you have to think about having quality of service guarantees, whereas what the agent builder system is going to do is it's just going to say like blah, here's a bunch of code, you run it, it's going to run through the workflow one time and then you're out. So there are a lot of considerations that are involved in moving things to production. However, I could easily imagine scenarios where you're a small company, there's a thing that you want to automate, you build it in agent builder, you grab the Python code, and somehow you set that up so that you can run it when you need to do it, right? So it really depends on the use case that you have. I would also point out that I think a great alternative, which might be worthwhile, is to use something like Claude Code. So if you're a little bit more of a coder, I suspect that you could bang out code using Claude Code that was very well written, and you could have discussions with it about how to scale up and get it to production quality and get yourself much closer. This was just me trying to make sure that there was a thing that was accessible. So if people see the webinar, they can just kind of go off and play with it on their own.